Well, as Dick said, I'm Steve Smith. I'm the manager of control system support at Eastman Chemical at our headquarters site in Kingsport, Tennessee. And if you're not familiar with Eastman, we're a specialty chemical company, now a global company. We have about 50 manufacturing sites around the globe now. Those are highlighted here on this global map with the red dots. We have customers in over 100 countries now. And as I said, we are headquartered in Kingsport, Tennessee. And if I had had a chance to see Michael's presentation beforehand, I would have added a slide in here because I don't argue with Michael that things are big in Texas, but I will claim that things can be big in Tennessee as well, in that our Kingsport facility is our largest facility at Eastman Chemical, and I know it to be one of the largest in North America. Now, I'm not saying it's bigger than Michael's because it's just one of, but I do know that it's quite large, and I wanted to give you some context in the size because it plays into some of the comments that I want to make today. So we have about 550 buildings on our site. If I had included that aerial photo of our site like Michael had, Michael noted to you the size of the cars in his picture. Our aerial photo would have been such that you wouldn't have been able to see cars because it would be zoomed out that far to encompass the entire site. We're over 4,000 acres, although the bulk of those buildings are on 900 acres of that. But if you talk about it from just an automation standpoint, our site is almost 100 years old. We're coming close to our 100th anniversary in 2020. So we have a lot of aged assets as we do with automation. We currently have over 60 DCS systems, almost 800 PLCs at the Kingsport site. And unfortunately, because of our standardization or lack thereof, I should say, we actually have, just in the DCS arena, systems from over 6 manufacturers, technically 5 due to an acquisition, but 6 manufacturers' systems of just DCS systems. And if you consider all of the generations of those systems and the variety of engineering tools, it's really over 20 different platforms of just DCS that we have at this site that my organization has responsibilities for supporting on a day-to-day basis. And so, as you can imagine, that is a huge challenge for us. And so because of the size of this site and because of the age of the site, we're on any given time engaged in several major automation projects in the terms of just modernization. We are not building many new greenfield sites, as you can imagine, at this site, but are going through a retrofit process from an automation standpoint. And so that's really what I want to share with you today is about one of those projects that we currently have ongoing. And in talking about some of the things that both Dick and Michael have mentioned, you know, when we go through these automation modernization projects, there's a couple of different thoughts and camps, as you're well aware. You know, sometimes when we talk about the major modernization project that we find ourselves in because of the number of suppliers we have, we are working to try to minimize that footprint as we go forward. So oftentimes these modernization projects are almost rip and replace projects in that we're taking a system out from one manufacturer and replacing that with one from another manufacturer, which obviously means we're not only replacing all the hardware, but completely replacing all of the software as well. So one camp would say, wow, that's such a major project with such potential impact to the end users, especially the operators, we should try to minimize the change and keep as many things the same as possible. I tend to be on the other camp that says, wow, there's not any better opportunity than now to really take advantage of this new system, new technology, new features to really do things differently and, in my opinion, to do things better. So that's really the approach that we are taking in our modernization projects. We're really taking this opportunity when we go in and put a new system in like that, essentially from scratch, to do a much better job around alarm management, high performance HMI, and what I'm going to share with you today is around interlock monitoring. But we really decided that that's a great opportunity for us to really do things differently because what we find, again, because of our site and our resources, it's well and good to say, well, let's keep things the same and get the system in and let folks understand the new system and then make those improvements, but we find that that never happens. You know, as soon as you finish that project and you get it in, you've just invested a tremendous amount of time and effort. It's very difficult to come back and do something of a significant nature, especially when you're on to the next project. So we really see the time being now in these modernization projects to do some things radically different, and that's what we're doing. I also wanted to make one more comment before I get into the details here about Dick's comments about the whole Mac approach. We were one of those companies for a number of years that Dick described in terms of doing everything in-house. I know 30 years ago when I started at Eastman Chemical, we did all of our engineering, all of our construction, and all of our automation work in-house. In fact, I remember the very first users conference that I went to about 25 years ago. I was meeting with dinner with one of our suppliers at that time for that user conference, and there were some other customers there with me at dinner. And I remember during the course of the conversation, it became apparent that I was doing DCS configuration rather than the supplier doing it. And I remember they questioned me about that, and I thought that quite odd that we were doing the work, not the supplier. But that has historically been the case at Eastman, even today, that we do most, if not all, of the work in-house. However, we are now taking a new approach as far as this Mac concept. In the project I'm going to share with you today, we've engaged with Yokogawa to kind of serve in that role from a supplier standpoint to provide a lot of the automation on this work, this project up front, as well as some of the other activities that Dick described that a Mac will typically provide. So let's talk about interlock visualization a little bit. That's what I wanted to focus on in terms of an improvement opportunity that we've taken advantage of in this multi-year modernization project that we're engaged with Yokogawa. So certainly, if you're familiar at all with automation and projects and operations, you know that limited interlock visualization is undesirable. It's undesirable anytime, but specifically during some of these times of what I would say are non-steady state operations, whether it's startup or shutdown, or you're in testing periods or maintenance or troubleshooting issues in the plant. And if you spend any time in the control room, you've probably heard similar comments like this from staff, whether it be the operators or maintenance personnel or such, that, you know, there's been some type of activity in the system, there's been one or more interlocks tripped, and we're really not certain what's happened and why and where we need to go from here, and they're calling for help or looking for assistance. So what I've termed invisible interlock logic is often frustrating, especially during these times of non-steady state operation. And that's certainly been our experience and one of the goals in this project to improve upon. So what were some of the key problems that we've experienced, and I imagine you've experienced as well from a standpoint of interlocking? They certainly impact production. I mean, obviously they're in place for certain reasons, both from a quality standpoint and a safety standpoint. But when they occur, then basically they are preventing production, and we need rapid resolution of those to move forward and to restart or to recover. Just identifying the causes in the trips oftentimes is challenging. We know that a trip has occurred, but why did it occur, and have we corrected the problem to be able to move forward? How about just the reliability of the information? Depending on how that information is presented can really depend on how much we even trust that information and whether we even use that information or that system for us in our resolution. And I wanted to note that throughout this presentation, you'll see the term end user rather than operators. And I could have certainly said operators here, but especially from an interlock standpoint, we see that the interlock system that has been developed here is not just the benefit of the operators. It's also a benefit to our maintenance staff. It's also a benefit to our engineering staff, as well as anyone else that's interacting with that system and that process. I know for years, and I was guilty, or maybe this was, I shouldn't say guilty, maybe this was our only option at that point, but I have built myself, as well as many other folks at Eastman, custom interlock displays to try to provide some of that dynamic visualization to avoid some of these problems. Those are very costly to create up front and very challenging to maintain going forward. And then in general, you know, interlock information tends to be scattered over a whole host of repositories, and managing that can certainly be a challenge. So what are some options just in terms of trying to work through these situations? And I can say that we currently have many examples of these active in our site today across the various platforms that we currently have. One is just to rely on the control systems engineering tools. when and if there's an issue, you're calling in the system administrator, you're calling in the control system support person, you're calling in the control system engineer, allowing them to basically get into the engineering system of the process to basically determine what has happened from an interlock perspective. Another is to utilize those custom displays that I just talked about. Again, can be very costly both initially and from a maintenance standpoint. Can still be very limited in functionality. Even though they're dynamic in nature in terms of the information they're displaying, they're fairly fixed and static in terms of their overall presentation. Then there is now some built-in functionality. Of course, in many of our cases at Eastman, because we have so many legacy systems, that built-in functionality is not present in a number of those platforms. But if you do have any newer generations of systems now, you know that suppliers have made some great strides now in terms of building some much better interlock functionality in their systems. That is still somewhat limited though, especially in terms of drill down capabilities and looking across the entire system as far as interlocks are concerned. And then there's the option of a custom solution in terms of building something within the system on top of all of these functions that you have, and we have done that as well. And that was really what was kind of the seed and the initial birth of this whole effort, was an effort that we had inside Eastman Chemical to build a better tool that addressed a number of these problems for us. But once we did that, we found again it was very costly. We really had it tied to the individual who had created that, and when they retired we found that we were left really struggling for support and supportability. We also recognized it was going to be a challenge to maintain going forward as the supplier made changes in their system and or Microsoft made changes in their OS and such. And so we didn't really feel like that was a desirable solution for us as well. So we really felt like there was a better solution there that we wanted to pursue. So what did we want that better solution to look like? We really wanted a single view of information. We really wanted direct access to the interlocks in the control system itself for both interpretation and resolution of the issue at hand. We wanted a comprehensive view that also had built-in navigation and drill down capabilities when looking at interlocks within the system. We wanted the information to be reliable, so we wanted this to be a robust application that was heavily tied and built within the control system itself. And we really wanted this to be out-of-the-box functionality. We really wanted to try to get away from this whole concept of customization in terms of the build and in terms of configuration. And then really overall, we obviously wanted ease of use. We wanted it to be simple to configure, we wanted it to be simple to use and simple to interact with on all fronts. So with those desired I guess, characteristics, we basically engaged Yokogawa in this project and asked them to work with us and partner with us in basically building what we felt like was a better solution. And so the solution that I'm sharing with you today is actually that product of this effort that we have now employed and are employing on this project and will employ on future projects similar to this. And so the benefits that we really are expecting to gain from this is certainly improved operations. We feel like with this tool we will have much more rapid and reliable access to the interlock status within that unified environment that I described. We really expect to see reductions in our production delays, specifically due to interlocks. We expect to see much faster resolution when those interlock situations occur and when we know we've got issues in the system and we're troubleshooting those, whether they're interlock related or not. We really see this to be a much more effective end-user interface for us, especially in terms of the interlock visualization. When we do have operational issues, this is a place that we can go to easily and quickly to either rule out or to resolve the interlock conditions. And it's really helped from an HMI simplification standpoint and from a resource utilization standpoint. If you're building those custom displays, that's a tremendous load on the system. And so without us having to do any customization around our HMI displays, it's really freed a tremendous amount of resources up in our system and simplified our other HMI displays that we've had to create. And then we also are expecting to see a reduction in just what we would say are preventable shutdowns. Anytime that we're doing planned work in the system, whether it be in the field, or in the process, when we know somebody's going out to work on something, you'll see in a minute, this provides us an excellent tool to proactively go in and understand the potential risk involved in terms of tripping the system or triggering interlocks as a result of that work. So I've got a few screen captures here that I want to just again highlight some of the features of this tool that Yokogawa has created for us and embedded into their Symptom BP product. We first have on our HMI displays this context sensitive pop-up so that if and when you've got a tag that could be an initiator or a device that could be an actor, a right click on that device will launch this unified interlock environment, and it will automatically pre-filter that environment for that tag or for that actor. If you look at just this overall visualization, as I said, it's in a unified, it's basically a web. It comes up in a browser, an Internet Explorer window, so it is web-based. It basically identifies all the interlocks via initiators and actions. So on the left side here, you'll see a listing of interlocks, and then for those interlocks, the associated initiators, and for those initiators, then the associated actions. It's filterable. If you notice on top of the display up here, when you create the interlock within the system, you have the ability to make some assignments from a hierarchy standpoint in terms of the plant and the area, then the interlock name and the associated initiator and actor name. And so I mentioned a minute ago, if you use the pop-up context, it would pre-filtered, but once you're into the system, you can go in and adjust any of those filters to basically look at it from an interlock perspective or an actor perspective. So for instance, if I knew we were going to be working on a valve or a pump, I could come in and look at that specific device tag. It would automatically filter that list and show me all the potential initiators that basically would have affected that device. And then likewise, if I was working on a transmitter, I could go in and look at that specific transmitter and it would show me all the potential actors that that transmitter might trigger that would be an issue for me potentially within the system. And then as you notice as well, all of the blued filled in there, those are hyperlinks, those are clickable. So again, when I'm looking at this, that's another mechanism for me to filter and drill down. If I'm looking at this and there's a specific initiator I'm interested in or a specific device tag, a click on that specific tag there will then conduct the filtering for me again automatically and drill down into that specific initiator or that specific actor. And then there's also some other indicators that come up. If you see some of the shading behind some of those rows in the fields in the listing there, the user of the system has the ability to mark any of these initiators or actors as what the system calls important. And so those are there marked in kind of the, I'll say the rose or the light red color there, so that causes those rows to kind of stand out to the user. Those can be dynamically turned off and on depending on the nature of the system or the process. Likewise, I talked about having more reliable information in terms of this unified view. And so if you see some of the other fields that are highlighted that have either an unknown or a bad status, those are cases where that tag for some reason is not reading properly. So that you're getting some feedback there that that information is stale or inaccurate at that point and unreliable for some reason. So some other features as far as configuration, this has a nice import and export capability, so we can do work in Excel basically and do a bulk import into the system of our interlocks, the initiators and the actors. But it also has a nice web interface to where you can work within the system on a tag by tag basis to make changes and or configure new tags, both as far as initiators and action. All menu driven, very easy to use and interact with. And then it also has an audit trail. So as you're doing work within this system, it will flag changes that have been made in the system as well to let you know of recent changes or corrections that have been made throughout the system on a tag by tag basis. So I guess in summary, we really feel like that through working with our supplier in this case to try to take advantage of this modernization and make an improvement here, we feel like we have arrived at a better solution in terms of interlock visualization. We really feel like this tool now replaces our need to build customized solutions and/or interlock displays within the system. It's certainly integrated tightly within our ICS, and it integrates with our other HMI displays that we have there and really provides a nice, quick mechanism for us to troubleshoot issues within our operation. And it is a very nice comprehensive view of the interlock information in our system. That one web browser is the single and only necessary interface to basically look at this information with complete navigation and drill down capabilities in that single window. And again, it really helps us to avoid production delays through rapid access to this interlock hierarchy and information. It shortens our project implementation time. We're now no longer building those custom displays. We're not doing a lot of other work to try to address visualization of the interlocks. And then likewise, it's really reducing our overall configuration lifecycle cost and resources, because now we don't have all these custom solutions in terms of graphics and displays that we build around our interlocks that then we're having to try to maintain over the life of the system. So that was a quick example of one of the things that we're doing to try to take advantage of our modernization projects, much like Michael had mentioned, in terms of there being a whole host of opportunities for improvement. So, thank you.